So on behalf of the Bahá'í Chair for Studies in Development at Devi Ahilya Vishwavidyalaya, Indore, I would like to warmly welcome our distinguished speaker for today, Professor Rajeswari Raina, who has very kindly consented to be our speaker for the Dialogues in Development series that we have been carrying forward for the past over a year now. And also I'd like to welcome all our participants who are joining us on Facebook Live as well as on this Zoom session. The topic that Professor Raina will speak with us about is a very pertinent one for development, those who are concerned with development in India today, which is understanding interactions for sustainability, technologies, environment, and development in India. I won't say much about the theme because I'll let Professor Raina, do that. But before beginning, before asking her to share her comments, I just wanted to share a little bit about her. Professor Rajeswari Raina is a professor with the Department of International Relations and Governance Studies at Shiv Nadar University in Delhi. She has a background in the agricultural sciences and a PhD in economics. Her research is inter- and transdisciplinary, mainly in institutional economics, science, technology, society studies, and the substantive relationships that underpin agriculture, human and ecological well-being. Her publications and public engagements with governmental, academic, and civil society organizations and networks are on institutions and policy processes, post-growth possibilities, mobilizing public support, and piloting living soils, inclusive innovation, decentralized agroecological and social ecological systems of transformations, international environmental assessments, and knowledge-based bioeconomic capabilities. Friends, just a few housekeeping points before we begin. The lecture will be for around 40 to 45 minutes. After that, we will have time for taking questions and comments from participants who are joining us during this live lecture. Please post your comments using the Q&A box. So type your questions or your comments both during the lecture as well as at the end. And during the time allotted for discussion, we will take these comments and these questions and have Professor Raina respond to them. So without taking more time, over to you, Professor. Do let me know when you want me to begin sharing the PowerPoint.
Sure. Thank you. Firstly, this is actually an honor to be here and to speak at this lecture series. Many, eminent scholars in this country have spoken, policymakers and others have spoken at this lecture series. I've been watching them closely. So I'm really grateful that you've given me an opportunity to speak at this forum. I think we can start sharing the screen because we can just begin introducing the idea of this lecture and why I'm focusing on this question of understanding interactions. Yeah. So can we have this full screen? Okay. Yeah. Okay. Yeah. Yeah. So for me, this lecture has given me an opportunity to bring together some of my earlier work and some work that I'm doing now. So it basically draws from some earlier work that I did while I was a scientist with the Council for Scientific and Industrial Research in this lab called NISTADS, National Institute of Science, Technology and Development Studies. Well, the name itself suggests what the job description is, right? That is science, technology, and development studies. It is basically questions of how the two inform each other, right? So I draw on some of that earlier work and also on some more recent work on post-war thinking in India. Yeah, that is what kind of thinking is the Indian, well, let's say Indian growth thinking opening up for us, and two, how do we draw from this? That is, how do we draw from this for a more sustainable world, right? So what I've also done, with a little apology to those of you who have even bothered to read the abstract, and what I've done is to start with some illustrations that we are familiar with, right? And then we will question the ways in which we understand these illustrations of environment and development interactions. Yeah. So our focus in this lecture is on interactions. And these interactions, I'll show, are evident in the illustrations that we'll see. And what I also want us to do is to ask how this, well, let's say this understanding of interactions, well, let's say as evident in the environmental challenges and development, compares to our disciplines, whether, well, let's say speaks to our disciplines, economics, chemistry, physics, and so on, soil chemistry, if you want it, yeah, where the units of observation are things like incomes, commodities, prices, pH, or a cation exchange capacity, or boiling point, and so on, right? So there are specific units of observation in these disciplines, whereas what we need in this phase of massive sets of changes that we're going through now is more capacity to understand the interactions between these variables. Yeah, and that's what we're going to speak about today. So, well, these interactions that lead to specific outcomes, like prices, which we otherwise treat as causal relationships. So interactions are evident in our disciplines too. It's just that we're arguing that it's not enough, that it does not give us a clear picture of what is happening when environmental and development questions, well, are posed to us. So the two key points that I want to make here in this lecture today are, one, that, well, technology has become central to what we well, whatever we see today as environmental outcomes and developmental outcomes. Yeah, so that is, technology is what drives or shapes the nature of these interactions now, because the actors who are investing in these interactions are also shaped by a particular kind of technological framing or technological thinking, right? So we'll talk about that. The second point, the second key point that I want to make in this lecture, again, you know, some of these new texts that we read now has this you know, AI generated takeaways. This is a bit like that. I thought I'd start with that because our audience would carry this with them. So the first point is about technology as being central to these interactions between environment and development itself being the result of certain interactions. And the second point is that these interactions and the understandings of these interactions is absolutely essential today for us to do what? To help us reconceptualize technology itself. That is, to revisit what we mean by technology. Yeah, and also the question of sustainability. That is, how can we understand sustainability as a result of a set of interactions? Yeah. The next slide, please, Dr. Fasley. So, for us, the yeah, thank you. So I just very briefly want to run through these illustrations. And I said I removed a couple of slides, and I'm just going to speak about the illustrations from this slide here. That is what we see here as a key set of, well, let's say, interactions that I've some examples that I've given here. Something that we're all familiar with, right? So we have well, let's say a forest ecosystem. Yeah, so that is an environmental setup or a context yeah, with several variables. Timber is one of the variables. Non-timber forest produce is another set of variables. There are people who collect these. They are also elements or variables in the system, yeah. And you have, well, now new ways of, well, eco-friendly collection, more sustainable livelihoods from forest ecosystems as demands, which has resulted in a set of rules and norms. So we have, let's say, like I said, in a forest ecosystem, harvesting of non-timber forest produce as one of the activities, and certain rules and norms of community forest management that have been put together. So these are, well, both these are the result of interaction, right? So when we study, well, let's say, how community forest management has helped secure livelihoods as development outcomes, as good, stable development outcomes, one of the key things that we should remember is that the harvesting of NTFP itself and the community forest management norms are both the results of, let's say, outcomes of interactions that have happened in the past. So harvesting NTFP, for instance, the nature of NTFP itself, right? It is a range of properties that evolve within a forest ecosystems, emergent properties, buffers, redundancy, connectivities. These are all things that in the forest ecosystem, that is the ecological understanding of forests, will show us various elements and properties that evolve there as a result of various interactions within the ecosystem itself. And then there are social systems, that is social systems involving the state too, yeah, where the state, let's say it could be a local panchayat, it could be a department, Ministry of Forests, yeah, which puts together a certain set of community forest rights and gives people the rights to use them sustainably, yeah. Now, all these are sets of interactions that give you these, well, let's say, these outcomes. And these outcomes themselves are processes that happen, right? So we have to remember these as crucial, well, let's say, information coded into the ways in which we understand our system, right? So rice wheat cropping system is another one of my favorites, but my work has mainly been on the agricultural sciences. So rice wheat cropping systems, when did rice wheat cropping systems come about in India? Of course, the Grain Revolution. But immediately after the Grain Revolution? No. So immediately after the launch of the Grain Revolution, not then. But it took about almost a decade for the rice wheat cropping system to come about as the system in India, especially in the Indo-Gangetic plains, right? Now, if you look at where, well, the kind of technologies that facilitate these, yeah, like for instance, a social technology that we see here in the previous illustration is the community forest rights, community forest management tools. Similarly, another set of social technologies, that is technologies that enable this, is the financing of tubers, subsidies for tubers. Again, both are the result of a set of interactions, right? Groundwater irrigation and soil salinity, again, one of my favorites. Illustration in terms of what happened in Punjab. For instance, the Indo-Gangetic plains, we forget that about 80% of irrigation comes from groundwater systems. Yeah, and these groundwater systems, especially in a region like Punjab, which is arid, semi-arid, the state has less than 600 mm of rainfall. It is not a region that is suitable for the cultivation of rice, yeah, which is basically a wetland, riverine ecosystems, well, wetland paddies, as we call it, right? So these systems are, well, let's say, have been institutionalized with a series of, well, support systems, institutional changes that have facilitated the cultivation of rice through the use of that is groundwater irrigation. Now, why groundwater irrigation and why well, let's say the question of soil salinity, we'll come to that in a bit, yeah. For us, these small illustrations, that is just to say what these illustrations speak to, how they speak to our concern about well, interactions. We have to see that all these, well, rice wheat cropping system as a cropping system that emerges is the outcome of a set of interactions. Harvesting and TFP is the outcome of a set of interactions. Institutionalization, again, all the tubal subsidies and all these things that encourage groundwater irrigation. The, well, fuel subsidies, free electricity, for instance. Yeah. So these are, well, the kinds of interactions that lead to these. One, there is a politics to it. We don't want to discuss that today. What we want to just emphasize today is the fact that we have to have a better understanding of interactions, yeah, and see these environment and development questions as outcomes. And they themselves are processes that evolve. And as they evolve, they create new elements and processes. One of the key, well, let's say, themes that I introduce in this lecture is that there is a change in the ways in which there has been a significant change in the ways in which we see technology, in the ways in which technology itself is well, let's say, conceptualized since the 1960s, since 1950s, 60s. Yeah, technology is increasingly, well, let's say, seen as embodied capital. It is something that has to be manufactured somewhere as an artifact or a commodity and supplied to the users. Yeah. So in the case of agriculture, for instance, especially in the case of the rice wheat cropping systems, what you see is there is a production of these technologies, an investment in the research for the production of these technologies, the nature of the distribution of these technologies, the utilization through subsidies, whether it is fertilizer subsidies or irrigation subsidies. I mean, you have subsidies for all these, right? So the gist of this, that is what we want to draw from these illustrations, what we want to see as well, let's say, the problem here is that we tend to ignore, that is, in our focusing on yield from Punjab, yield of rice, yield of wheat, irrigation intensity, you know, all these kinds of, well, let's say, individual variables, which are the outcomes. Yeah. When we focus on these, what we ignore is a set of interactions, the ways in which these variables interact, the ways in which processes in both social and ecological systems interact and evolve, and the patterns of interactions that are institutionalized, again, institutionalized by the state, yeah, but by the state with a set of other actors who are involved with the state. And therefore, it brings us to the key question of how do we go forward? We know that we are an unsustainable system. Yeah, that's kind of taken for granted, right? So in order to go ahead, that's the crux of this argument, that is of this lecture, that is the key message here. In order to go ahead to a sustainable future, we have to investigate these interactions a little more carefully. And for that, we need a different lens. We need a different lens that comes from an understanding of what we call ecological economics. Yeah. So the question is how we theorize these technologies and their application to these environmental and development questions. Yeah. Those are, well, important questions. But if we do not see the interactions that lead up to these outcomes, then we miss out a crucial chunk of what is actually happening, right? And therefore, we need to question the available theorization of technology and the application of technology too. So the next slide, firstly, please. So what I've done here is something that I do in my undergraduate class, basically present to all of us here the idea that interactions between, well, let's say, the social and the ecological, the social and the environmental, can be presented through different lenses, through different, well, what we call schools of thought. Yeah. So in the conventional neoclassical economics, development economics, given to us as the theories of development, yeah, in these conventional schools of thought, which we call the Mickey Mouse model in my undergraduate class, we see the economy as a relatively autonomous system, somewhere up there, ethereal, you know, kind of a kind of non-attached kind of existence. Yeah. And it can draw endlessly from social and environmental systems and dump back endlessly into the social and environmental systems. So what we see today as climate change, what we see today as a major set of environmental challenges, whether it is groundwater depletion or whether it is pollution, whether it is air pollution in Delhi. We often blame the farmers every November, we start crying about farmers burning stubbles. Yeah. But like I said, why did farmers start cultivating rice in this arid state in the first place? It has canal irrigation, it has 5 rivers, as the name goes, Punjab, yeah. But why did they start cultivating rice in such a massive manner? That is, it covers 98% of the arable land of the net zone area in Punjab during the Kharif season. It shouldn't, right? It should still be cultivating rice in one little waterlogged pocket in Faridkot or somewhere, not the entire state. Why did they do that? It's because of this model. That is, you can think about the world in this way and you can institutionalize a certain set of interactions this way. These interactions can also be seen differently. Like you can see this as one little arid land, one little, well, let's say state that is arid, semi-arid, well, rivers flowing through it, but the groundwater system is pretty weak. And well, there are social systems within that biophysical space and an economy within that. Yeah. In other words, once you reconceptualize that is the ways in which the economy, society, and the environment interact with each other, we have a very, very different worldview. And this worldview then is important for us to understand and, well, in some sense, tackle the problem of, well, sustainability. Yeah. Again, I'm not saying give solutions to, because, well, it's not like prescribing solutions. The solutions have to emerge from this system, from this social system itself. It can't be imposed from outside, because the social system has to reconfigure itself and ensure that these interactions between the economy and society, between the economy and society and the environment are maintained in a sustainable way. Yeah. Now we'll come back to this framing question at the end of the lecture. Yeah. Dr. Fazli, the next slide, please. So I'm just going to use 2 examples just to illustrate what I said now. That is, our framework, that our technological thinking, that is, our thinking about environmental and development problems through a kind of preconceived, in some sense, foreordained, well, trajectory is evident in 2 extreme cases. I'm using the global climate change negotiations and the climate dialogues, climate friendly technologies, and also very localized, very, 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 well, let's say ecosystem specific, agroecosystem specific case of natural farming, agroecology. Yeah, I'm using these 2 as illustrations to just show how we think about this. So I've just highlighted a few points here: wind energy, solar power, and hydropower. Yeah, drought-resistant crops, early warning systems, and sea walls. Yeah, to keep the sea out as if you can. Soft climate technologies such as energy efficient practices and training. All these are listed as climate technologies. Yeah, and well, who's going to do this? That is, the developed countries will well, let's say, carry out this. That is, enable these technologies, and they will ensure that financial resources and transfer of technology takes place to the developing countries, yeah, to other countries or to anybody else for that matter, yeah, from the developed countries. Now, over the years, they say that adaptation has received increasing attention, fine. And now for implementing these, that is, for implementing these and to realize what, well, let's say what resilience is, that is the ability of, well, different ecosystems spread across the world to be able to withstand the shocks that climate change will bring and to bounce back to normal. Yeah. Now, even there, they have devised, that is, the UNFCCC and its, well, international assessment experts have devised a technology framework to provide overarching guidance. Yeah. Now, what is problematic about this? One, it doesn't see these entire set of what we saw in the previous slide, right? About the environment, that is a local environment, the local regional environment, and social systems embedded within them, and the economy as a subset of these social and environmental systems and constant interactions between these 3 is completely erased here. It doesn't exist in the system. What you have instead, you have what is, well, a typical Dennis Ronald Denley, well, framing of of, well, it is his criticism, of course, of, technocentric thinking, selective perception, target and control mechanisms, typical development technology thinking, right? That is, you can use technologies through a selective perception of the problem, through target and control mechanisms, and you have your technocentric vision come true because you can just apply the solution to whoever's out there to receive it, right? The other extreme, at the other extreme now, we have the next slide, please, Dr. Fazli. At the other extreme, we have, well, very, very localized natural farming experiments, agroecological systems, allegedly very, very low key, very poor in technology, no fancy solar or hydropower or, wind power equipment, and no technology transfer coming from anywhere else in the world. It all has to be localized. It has to be very simple and straightforward and, well, located within a particular ecosystem, adapt to that system, and so on, adaptable to that system, right? So what you find in the Government of India webpage on natural farming is this concept. That is, it says what natural farming is about. Yeah, it is well, the same words. Yeah, resilience to, well, different kinds of shocks. Well, that is what you practice in the field helps in various ways. This is what the concept is. This is why you need, well, natural farming. The next slide, please. I'm just going to go through this. And to continue, it involves specific principles. Yeah, specific principles like we saw in the previous climate change case. Specific principles like a technological framework, right? A technological framework that will then set the tone for these actors to act, right? That is allow the developed countries or the local farmers in these localized ecosystems to act on their, well, production systems and distribution and consumption systems, right? So the same web page, yeah. Now, let's take a look at these principles a little carefully, yeah, and see why they are different from, why do we think they are different from what we saw in the climate change example. Technology is central to this too, yeah, technology. So diversified cropping systems, yes, it is a technological change. Recycling technologies, recycling of on-farm generated biomass, again, technologies, locally developed and refined practices based on plant, animal, and microbial source as raw materials, again, technologies, innovative practices, technologies again. Now, what do we see different here? It's basically the natural and social actors involved. These are not natural, this is not just a context into which, well, the economy, well, does it financial and technological or financial assistance and technology transfer to agro ecosystems. The natural and social actors in each ecosystem are deeply involved in all these. That is, they have agency and they have a voice in shaping and enabling the enabling the evolution of technologies in each agro ecosystem, right? So let's just look back and say, well, if technologies can be this too, what was it about the previous technology that we saw as problematic? One, as I said it right at the beginning, the embodied capital lens. That is, when you see technology as an artifact, as a set of commodities that have to be produced, if possible, with massive subsidies from the state, yeah, and transferred to people out there, yeah, then you have the first view, that which is the climate change technology view, yeah. Typical agriculture technology view also, right? Modern agriculture technology view also. And if you see natural and social actors, as we saw in the ecological economics framework, as located, embedded within each other, then you see that, well, they have agency, that they have constant interactions, and that these interactions enable them to sustain certain variables and to sustain certain processes that ensure resilience, right? So why do we then do this comparison? So you must, I don't know how many of you have seen this, but every now and then you see a report coming from the Indian Council of Agricultural Research, the State Agriculture University in Gujarat or Kerala or Karnataka, saying, natural farming and organic production systems, the yield per hectare is just as good as conventional farming after 3 years or 4 years of what they call a transition period, yeah? Or yield is not as good, the cost is more, that is expenses in terms of monetary expenses are much more, and therefore they are not good. So there are these constant comparisons, but the unit of observation is yield per hectare. Why do we still use that? Why can't we compare, well, these principles and the interactions, including the actors involved in them, and find a template to do that? Now, the problem is, which is actually a bit sad, because the problem is that ecological economics as a transdisciplinary arena has developed some of these methods to do this comparison, right? It's got the social metabolic analysis that looks at the social metabolism of an entire system. It could be an entire country, a particular sector, but again, the kind of boundaries drawn is problematic, but still you can do that. You can do a material and ecosystems analysis, that is material and energy, basically an analysis of how the system flows. It is material and energy flows across a system. Yeah. So you can do a MEFA analysis. It's not for lack of methods, but it's for a lack of understanding of interactions that we don't seem to do this. We don't seem to accept that these interactions are important, that these interactions are important, and that we have to have a way to document them and analyze them. Let's just think about some of these traditional systems that we've seen. Most traditional agricultural systems have, well, within them, most traditional forest ecosystems and people living in forests have a map as in not just a, well, let's say a historical, sheet of paper with a map on it, but an intra-seasonal, intersectoral map of interactions with them. And this is what is, well, let's say, different, absolutely different in traditional thinking. That is, in traditional as in not, in a conventional, well, let's say religious way or anything, but just that traditional old systems that think about interactions and not just about an outcome, right? Yield per hectare is not an important variable. Yield per hectare is one of the indicators, if at all. So why do we do that? Can I just have the next slide, please? So the reason why we do this is because certain patterns of interactions have been institutionalized in our minds, right? And these patterns of interactions, for instance, we think of land as, well, the unit of observation. Yeah, we think of labor as a unit of observation. We think of capital as a unit of observation. And gradually, we also take in land as one of the forms of capital, right? So land is also a form of capital, and it's natural capital. So there goes. Economics then erases our ability to think of land as a natural actor acting in its own way, yeah, that is, well, imbued with qualities, properties, well, systems that make it an actor with agency, right? Now that's gone. You've converted that into natural capital already in our mainstream discipline, right? So let's take a quick look at this because I'm running out of time too. If you look at all these, well, let's say patterns of interactions, let's just think about each of these during different phases of Indian or global changes in environment and development. You'll find that these are all conscious choices that we have made. Conscious choices made for, well, allegedly environmental health, developmental outcomes, and so on. The last one that I want to focus on, I mean, because the others we've seen, I mentioned this in parts earlier. The last one, that is climate change and changes in agri-food systems. Well, for instance, we can have, if we have a mapping of carbon emissions, the drivers of these emissions, the ways in which some of these drivers already have alternatives locally and need not be the same across the world. Transport, for instance, need not be the same. Plowing as an activity need not be the same. Land preparation, crop systems need not be the same. So we have alternatives across the world, right? So we can have a carbon tax based on an understanding of interactions that lead to certain levels of emissions, reduce them, and tax them before, that is, even as people create these emissions. But no, we are now encouraging carbon trading. where people, individual units, whether you're industry or agriculture or whatever you are, you're allowed to emit as countries, as nation states, and then trade your waste, that is trade what you emit as, well, carbon trading points with financial assistance or technology transfer. Now, this is as perverse as the world can get, just because we don't pay attention to the interactions that, well, are very well documentable or have been documented in the past, yeah, and, well, allow for preventive action. I'll go to the next slide, please. So this is what a technocentric framing does to us then. So a technocentric framing gives us, well, because you think that there are technologies that can solve the problem, you forget, well, the kind of politics that is embedded in this thinking, and you also just, well, buy into it because the entire system has bought into it, right? The problem definition now is carbon emission, not the economy that is seen as a kind of ethereal superstructure that is dictating terms to society and the environment. Now that is the problem. But because we have erased all these interactions from our minds now, the problem definition is that of carbon, or let's say unsafe and unsustainable agri-food systems. Yeah, but the drivers, the interactions that lead to these are erased. So selective perception, it has to be ahistorical, socially and politically cleansed. Yeah, so you have all these listed here as, well, ways in which a technocentric framing helps us erase, well, what we see as the key drivers of the problem itself, that is the interactions that lead to the problem. Yeah, so we see an environmental problem or a development problem. A development problem defined as, let's say, it could be doubling farmers' income. Yeah, if farmers' income is low and therefore we have to double it. But as you double farmers' income, the income of others in the country would increase by, well, 10%, 10 times, 20 times, 500 times. That's not the question. If we are serious about, well, farmers' well-being, we have to, well, ensure that the interactions between farmers' incomes and other incomes are maintained with some level of equity, well, some norms in place to understand these interactions. Yeah, I'm running out of time now. I'll just take another 5 minutes. So what we need to therefore, because these, like I said, these are institutionalized, we have to find a way of opening up these institutionalized forms of, that is, patterns of interactions. Institutionalized patterns of interactions are the most difficult to break because we are still arguing about a minimum support price for our agricultural prices here, instead of saying, why? Why do we have to assure this if farmers' well-being can be assured through other ways? Yeah. Minimum support price was one way to do something, but it was important perhaps in the 1960s, but it did not continue like this the way it is continuing now. Yeah, that's hurting both agriculture, the farming community, and the nation state. Yeah, so we have to think of alternatives, but these thinking about alternatives is becoming impossible today because we are stuck in a, well, a certain pattern of interactions. Yeah, so Dr. Fazli, the next slide, please. This is just to illustrate how this patterns of interactions changed over time. Yeah. If we look at Punjab, where I said Punjab has 98% of the area of the Kharif area under rice, that is, Kharif is this crop that is starting now, June onwards, they start sowing rice, right? So, and harvest in October, November, when Delhi will then choke with the burning of the stubble, right? So why does Punjab grow rice? Did Punjab always grow rice? Like I said, no, it didn't. Yeah. Now, if we want an answer to Delhi's air pollution, if we want an answer to Punjab's rice cultivation as a problem, yeah, Punjab's rice cultivation happened as a result of a problem. Punjab's rice cultivation was its answer to, well, standing water being able to leach down the soil salinity and alkalinity to the bottom of the aquifer, where standing water loving crops like rice was needed, right? Because when you apply gypsum as, well, let's say as an amendment to leach down those alkaline salts that accumulate on the surface of the soil and destroy the soil quality, not allowing crops to grow well. You have to leach it down, applying gypsum. Now, price was the answer to it. Yeah. So again, another vicious circle that we have created. Yeah. Punjab, as you see here in 1970-71, had a tiny fraction of its land under rice. But now you have, I mean, now as that few 2006-7 here, but it's the same here even today. Yeah, it could be 2024, 25, it's still the same. So it's a massive increase that starts in 1973-74, along with something called gypsum subsidies. This is just to illustrate how we by ignoring the intra-seasonal and intra-seasonal problems, the inter and intra-system problems, well, interactions, we need, well, we put our neck on a nose, right? We've just decided that Delhi's air pollution will happen because it's what has had to happen. The next slide, please, Leslie. So this is again another illustration. I don't think we have time for that, so I'm just going to skip that one. And get to this slide where choices, that is this, like I said, patterns of interactions, right? Choices are not just made just out of thin air. They have been theorized for us. They've been theorized based on the development experience of developed countries, at least one or two major developed countries. Yeah. And what worked in those countries is what is being transferred to us as not as in, you know, just India, but any other part of the world. Yeah. As the development experience that we should all vie for. One of the key problems that you see in agriculture today, for instance, there's a good report by Dr. Bhattacharya and others on what is capital formation in agriculture and capital formation for agriculture. When you make, well, let's say capital investments, for instance, in fertilizer factories, in building dams, and so on, you are investing capital, that is the state is investing capital for agriculture, but in other sectors. Yeah. And what happens in the farm, that is in the farm sector, in agriculture itself, it gets all the subsidies, right? Again, subsidies not as farmers getting subsidies, but those who supply, that is both with capital formation, that is allowing capital formation for agriculture, that is outside agriculture industry, and by subsidizing these. Again, theoretically, both are supported in economics. Public subsidization of private capital and capital formation for agriculture. Now, these are, again, you know, great theories that we have seen that have supported the kind of, well, let's say, erasure of linkages, that erasure of interactions from our minds. The high payoff inputs model, which developed in which is basically the Green Revolution model, that is, if you have, well, a certain amount of inputs supplied to the farm sector, to quote Ruttan, where you have the state, which has the capacity to design investments, yeah, where investment designed to make modern high payoff inputs available to farmers in poor countries. Yeah, if you have that investment, exactly that. I mean, if you look at it, nothing has changed, right? The same thing that happened in the 60s with agriculture that is happening with climate change today, right? You have to have investment designed to supply these technologies to poor countries who will bear the brunt of climate change, right? So it's in some sense, well, reminding us also of another, well, it's not really institutionalized, but the circular cumulative causation that is a different way of thinking about the world, not this institution, not this way that is capital intensive technology choices that we've seen. So for us, well, let's say I'm just going to mark this out as a different, that a circular cumulative causation doesn't sit with this, and I should have specified that. That is the other four, that is capital intensive technology generation, to address certain selectively perceived environmental problems or development problems. Yeah, they are being implemented this way. They are being made available to us this way because there are theories that support these. It is, there are theories. It's not for lack of theories, other theories, right? There are, like I said, ecological economics. I mean, there are other schools of economic thought that have other theories too. But this is, what we call patterns of interactions. Yeah, this particular, well, let's say, group of theories or ways of thinking about the world is the one that we have institutionalized, most importantly. Yeah. So next slide, please. For us, what can we do? I mean, let's say one of us is working with a small NGO, or we are doing some farming, or I'm teaching, let's say any of us who does these things as part of, well, understanding interactions and technologies. What can we do? How can we make a difference? How can we change these patterns of interactions in which we are also, well, cogs in the wheel, right? We are also part of the system. So what can we do to change these? One is to just break it up, to deconstruct this into tangible and intangible resources, into what is easier to produce, what is given to us as well, let's say, a set of stock that is very difficult to change, and a set of stocks, funds that are available on a daily basis, things, people, learning capacities that we can change. So what is easier to reproduce, and what is not so easy to reproduce and change? Nature, it's very difficult to change. You can't produce nature. Nature is given to us. Yeah, we have only this much, limited in its forms, and its diverse forms, and its agency. So what we have to do is to have, at the very least, a capacity to question crucial interactions. These small arrows that I've drawn at the base of this, which is basically this the set of, well, a little, well, let's say, ability to understand that ultimately it's our knowledge, that is, the ways in which we know things, which is, again, the reason why we as academics, we as people who are responsible for generation of, well, generation, acceptance, reproduction, or refutation of certain kinds of theories, we have a big responsibility, a big moral responsibility, yeah, because we are handling this massive intangible resource called knowledge, and putting the technologies that we generate with this knowledge into work on production capital, natural capital, and social capital. And we want to transform all these in ways that, well, hopefully will be more successful and sustainable. But what we have today is a kind of blinkered view, which does not even let us look at these interactions, which does not allow us the visibility to see these interactions, right? So if nature is today part of natural capital, then this natural capital is seen as part of the knowledge capital in a production function, right? So we don't even see these interactions. Let's, at the very least, let us start with breaking up these different kinds of, well, capital, resources, whatever you want to call it. Yeah? But let's try and make these interactions more explicit in our own worlds. I'm going to stop here. Thank you very much. That's the end. Thank you.
Thank you so much, Professor Raina. This was a really thought-provoking, very rich lecture. I wish we had more time, but maybe in the question, in your responses to the question, we can, and comments, you can share more. We have a good number of questions already. The first one I'll just read out. What about the interactions that come prior to technological development, like the way science is carried out and influences policy? Scientific knowledge that influences policy tends to be based on that which is measurable. Similarly, it is governed by who funds scientific research. So it is arguable that the changes have to begin with the way science interacts with the state and the market. I don't know if you want to take one by one or we read a couple of. Professor,
I think the next one also, I think the next one also has a similar take on political economy.
We cannot address these questions without taking into view the political economy view.
That is a state science view. Yeah, that is,
There's
so I think
no
I'll take these two together. Shall I?
Sure.
So the techno-capitalist paradigm, as mentioned in the second question, and the state-science interaction, as mentioned in the first question, are really crucial. And I agree with both of you that is, let's say, a step prior to the technology generation, right? And if the technology generation itself is influenced by these actors, and what's the scope for well, let's say, understanding interactions and ensuring sustainability. For me, and I mean, not just for this lecture, but for me, I well, let's say, do not take the view that technology comes from science alone. Technology comes from the interaction of several actors, and many technologies that we have today, whether it is the wheel or any of these technologies, the pulleys that predate science by far, science as an organized inquiry, as a form, systematic ordering of knowledge, codification of knowledge happens much later, right? So I put technology before science as something that we have all lived with, evolved with. For instance, the first industrial revolution, there was hardly any institutionalized science, right? There was some, yes, but not really. So technology, in some sense, so I go back to the view that, yes, if we are serious about interactions, if we are serious about understanding and mapping these interactions, especially the interactions between knowledge capital, not just as science, but knowledge capital as including science, right? And if we are serious about mapping these interactions between knowledge capital, social capital, production capital, and, well, natural capital, nature, which we have destroyed endlessly, mindlessly, then we can, well, reform science too, if we are serious about this. That is, if we my purpose in this lecture was to draw attention to the fact that these interactions themselves are not visible to us, and that we have to make them visible. Thank you.
Thank you, Professor. I'll read the next question because it may not be visible to all the participants. Thank you very much, Madam, for your insights. One thing that was very interesting for me was when you said we must change our lens to be able to grow towards more sustainable environment. My question is, how can we measure it? I mean, how can we know that this particular lens will be truly sustainable and not another experiment?
Thank you. That's an interesting question. It's a very, very rich question, because it talks about, well, to me, it reads like we're replacing one lens with another. I guess there are several lenses. I mean, Ashish Kothari and others have this book on pluriverse, right? That is, it is a world with multiple value systems, multiple, again, competing, collaborating, cooperating, mutually sustaining value systems. It need not all be competing. Yeah. So if you look at any of these systems, there are different lenses available to us today. It's just that we are so deeply embedded in a particular, well, what you call, measurable, well, let's say measurable as a tangible, measurable system, right? So how do we measure knowledge today? We measure knowledge using patents and publications. Is that the only way to measure knowledge? Of course not. There are several other ways to measure knowledge. Not everything has to be measured. Some of them have to be understood through the interactions that are healthy and sustainable. Yeah. Despite all this, well, successes in the Green Revolution, every third undernourished child is an Indian child today. Let's not forget that. Measuring it is important, but if you're a mother, if you're feeding a child, you know when the child is falling sick. You don't need a measure for that, right? But you know that the child is undernourished. You don't need a measure for that. You need a measure as a planner. I completely agree with you on that. But there are some things that don't need measures as in quantitative measures, but a qualitative understanding, an understanding of intangible systems. So that helps.
The next question is from Subhash Chandra, who asks, to what extent is the problem our linear models of learning as against continuous learning through action and reflection and continuous adaptation and refinement based on context?
Yeah, I think I would tend to agree. It's just that I would like to expand that a bit, not just based on context, but based on well, context, and also a question of justice, right? That is, if some countries are, let's say, designated to be, as we call it, exporters of high value foods, of coffee, of spices and whatnot, and remain the most indebted countries. 80% of the most indebted countries today are the ones that export these high value foods. Why are they indebted? Yeah. So not just the context, but also the question of justice. We have to bring that back to the fore too. So continuous adaptation and refinement is important. Thank you.
Yes, the next question is from Surya Prakash: how to ensure that the pursuit of a more sustainable environment through technology does not compromise the rights of vulnerable populations. It is essential to adopt inclusive and equitable practices, often in striving for significant advancements. The needs and rights of poorer communities are overlooked. I think to some extent you addressed that, but I don't know if you want to share anything.
I think yes, we have to. There is no going ahead as just a sustainable environment is not a standalone item. Yeah, a sustainable environment also has to have healthy, well, let's say, well-fed, reasonably satisfied people, right? Not just a question of again extreme inequality. We don't want that. That is also part of a sustainable environment. So it should not compromise the rights and demands, just demands of everybody.
Thank you, Professor. The next question is from Dia Chaudhary. How does the concept of resilience in ecological economics differ from traditional views on sustainability? And what are the implications for economic policy and environmental management?
Thank you. So this is again another interesting question about in ecological economics, resilience anywhere in the world, in ecological economics or in any discipline for that matter, is a purely biophysical understanding. That is any system that goes through a shock will be able to or should be able to bounce back to normal, right? But do we just want the current, well, undernourished social systems, or let's say biophysically low, right, in terms of their bodily capabilities and so on? Do we want them to continue like that and bounce back to the same normal? No, we don't want that. So ecological economics, helps us see these interactions that are sustainable. What's called a weak sustainability and a strong sustainability. In a weak sustainability framing, we would see the same system, the same poor system, the same unsustainable system bouncing back to some kind of resilience, yes. But the strong sustainability, it is the biophysical integrity of the system that dictates terms to social systems that can maintain themselves well and well nourished and well, reasonably happy in a system, right? So that is economic policy then has to look for the material flows through the system, be able to measure and incentivize the most sustainable, that is the most, well, let's say, socially and environmentally friendly or least disruptive activities. So economic policy should be trained towards, or let's say tuned towards, well, understanding the flows and interactions in the system, but measuring and sustaining, measuring and supporting those systems that are the least disruptive or most well, let's say productive and socially and environmentally friendly.
Thank you, Professor. Then I think this is the last question. What do you think about the position of the deep ecologists that we have to start rebuilding with new ontological assumptions about who we are as humans, how we are connected with each other and with nature? And I would actually build on this question. So in a sense, that would then also suggest a new set of values based on this new conceptualization of who we are. Then what do we value as a? So in a sense, is the question of knowledge? Then does it have to begin with something at that fundamental level for it to be resilient in the sense of being able to resist being co-opted by the dominant paradigms that are out there? So I just yeah, it would be helpful to hear your thoughts.
No, I get it. That's another very interesting question. Yes, I mean, some of these ontological assumptions have to be questioned. In fact, are being questioned. Yeah, I mean, suddenly, I don't know, you must have read some news items about, which is appearing in all the scientific magazines, about the orcas behaving very differently in the Mediterranean. They've been attacking ships, yachts now regularly, which they never did earlier. One odd event once in a while was what once in blue, never ever. So now it's become a pattern. Now, what are these changes? How do we understand these changes? How do we place ourselves as one among several other species that inhabit this earth? How do we place ourselves in, I keep saying this in my class again. So for nature, we are just tiny droplets of a huge water cycle. Yeah. What we are, I mean, our body is 75% water, fine. I mean, so what nature sees is probably not us with actors with agency and so on. So I think a little bit of that will help. But again, in ways that fortunately or maybe unfortunately, we are in a system which we hope will be ethical and just. And we have to look out for this species, that is the human species, but without causing further disruption. We've caused more than enough already, disruptions and degradations. We can afford to do things differently more than any other species on Earth can. We can afford to, we have enough to fall back on to be able to do well, reasonably well, with every comfort that we need without disrupting nature anymore. But it needs rearrangements within the human species, within the human social systems. Again, new interactions that we have to find and enable. But currently, these interactions are not visible. We have to at least visibilize them. Thank you.
Thank you, Professor Raina. With these these thoughts, I think we can bring this very stimulating lecture to a conclusion. Unfortunately, we are a little, we've gone beyond our time, but I'm sure this lecture has raised many questions in the minds of our participants, and this lecture will also be shared on our YouTube channel, and through that will reach many more of those who are interested in these questions. So thank you, Professor, for really taking time, and despite your many demands on your time, um, uh, giving us this opportunity to learn on these about these profound questions and issues which are so relevant for our contemporary times. I'd also like to thank all those who have joined us today on both Zoom and Facebook. And I hope we will have a chance to meet once again.
Thank you. Thank you, Dr. Wesley. Thank you very much.
Thank you so much.
Thank you, everybody.